Hey, welcome everyone. I hope you're having a great time with AWS reInvent, and thank you for coming after Adam's keynote. Can you please raise your hands if you are a Redshift, Amazon Redshift or Amazon Redshift Serverless user? Oh, full house. Look at it. I'm really glad. Thank you. How many of you, can you raise your hands if you have experienced pain points related to scaling when your workloads are varying, or there is some large jobs coming in? Few of them. All right, couple of them actually, more than couple of them. I do have a solution here, AI-powered scaling and optimization. We will talk about it, we will do deep dive, we will go into some demos. You will see it in action. I am Ashish Agarwal, a product manager with Amazon Redshift. I, along with my colleague, Tim Kraska, who is a professor at MIT, will do a deep dive into this new AI technique that we are bringing to help our customers. So here is my agenda. I will do a quick recap of Amazon Redshift Serverless. I'll talk about some success stories and pain points. And Tim will do a deep dive into the new AI technique that we are talking about. I will do 4 demos. We will conclude and then do a Q&A. So what is Amazon Redshift Serverless? It's an offering of Redshift where you do not have to worry about type of the nodes, type of how much capacity you need. You do not manage the infrastructure. Everything is taken care by the Redshift service team automatically. And the best part is it's pay-as-you-go model, meaning you only pay for the workload when it is active and you do not pay when it is idle, and that results in cost savings. Some key capabilities, it's automatically provisioned. It scales, it does automatic scaling. It does very good auto scaling when there is a high concurrent workload. It does ML-based workload monitoring and make decisions. It does automated backup. There is no maintenance window. It's available to you 24/7 because it's all automated patching. And you can get started very quickly. So how does the architecture for Redshift Serverless looks like? As mentioned, it's ML-based monitoring is done. The workload management is automatic using Auto WLM. There are background optimization jobs. There is automatic tuning like automated vacuum, automated key creations. The patching is done automatically. And you see, you can do your data lake queries. You can query your data on S3. You can do your federated queries, and you can connect traditionally that you are used to either your JDBC, your data APIs, or your favorite BI tool. So your experience is very seamless. You derive, lot of burden has been taken by the Redshift automatically. And customers have experienced benefits of it when they are using serverless. So let's talk about it. I'll take few examples here. Customer Playrix, a mobile game operator and creator, using Redshift Serverless, they were able to onboard 10x of more of their analysts because of the auto scaling capability. They experienced better performance and cost savings of over 20%. Because serverless decides when to scale when there is high concurrent workload, it was scaling very well. So they do not have to provision, worry about the capacity upfront. Similarly, there was another customer, Mosaic AI, and workload management provider. They use the auto-scaling technique for using the Amazon Redshift Serverless, and were able to manage their data pipeline, their data lake queries better, resulting in both performance and cost savings. So this is all great, but at the same time, we listened to our customers and they provided us feedback that their workloads are more varying in nature. Okay? By what I mean is, they have steady state workloads. They have ETL queries which require more memory, whereas the steady state workload requires less memory. And on other hand, they have data scientists and data analysts who can send, big jumbo queries that have a huge requirement of memory. And those workloads can possibly time out or can, cause disturbances to existing workload. So they were happy with the existing scaling technology, but they still want better responsive technology for the variable workload, which will scale even better. So we listen to our customers here, and that's why we went and built this AI-driven scaling and optimization technology. I would like to invite my colleague Tim to talk about this new technique and do a deep dive. Thank you.
Thanks, Ashish. So my name is Tim Kraska. I'm a director of applied science, and also, when I'm not working for Amazon, a professor at MIT. I'm going to talk a little bit deeper more about what we built and why we built it. So for that, I would like to use an analogy, and that is that queries are a little bit like shopping carts. You have a bunch of stuff in there, and you need to eventually check them out, which is like the processing of a shopping cart, right? So you have different work items in your basket, and you want to check it out. So the question is, how do you scale it actually? The typical way is that you have a range of counters which can work in parallel, right? So you have a certain capacity in your retailing business, in your store, and we normally refer to that as the base capacity or base RPU. So you set it up, it's essentially the numbers of counters you have. It just says on how fast you can do like parallel processing and other things. But what if you actually ran out of capacity, right? So one thing which we can do, which is a little bit harder for retailers, is we can very easily add another warehouse to it, like another store that's the same size, right? We can even add like a third one and even increase the capacity further just on demand. So a little bit more formally, how we do it today is actually we have a component which is called auto WLM, which looks at the numbers of queries coming in and makes a decision based on that. We also have like a thing which is like a query prediction model, which already considers, for example, the demands of a single query, and we use that information for decision making, right? And then we have this like base capacity, which you actually have to set up front. This is like essentially a knob you can tune in order to figure out how fast things should be, like how many counters you have in a warehouse. So now currently how the scaling mechanism works is queries are coming in, and we essentially look into how many concurrently queries are running at the same time. If the load increases, we add another base capacity to it, like another warehouse of the same size, right? So this is great, and our customers already love it, right? So we have our shopping carts with different work items. We have like a certain capacity in our store. We can even scale it up, the numbers of warehouses. Everything is good until you see this very large basket shopping cart coming up, right? And we all know that if you have been to a retail store at some point, like there's somebody coming up with the cart and everything queues up behind it, right? And if you have several of them, and I'm talking about the really big stores, I probably cannot name them, but you probably know which ones I'm talking about, right? It can really slow everything down, right? So more formally, essentially it's just like a large query comes in and the base capacity is not enough. You need to do more. You want to increase it on demand beyond this like numbers of selectors counters you necessarily have to process the query. Another issue we actually observe is like if workload pattern changes. So let's assume like you have your cluster set up, you sized it perfectly for, let's say, short-running queries, but you also want to process some ETL queries at the same time. If the base capacity you have is perfectly sized for the short-running dashboarding queries, but not for the ETL ones, your ETL workload might take too long. If you size this correctly for the ETL workload, you're overpaying in the moment you only have dashboarding queries running, right? The current recommendation in this scenario is that you actually split the workloads out, that you create one like Redshift cluster or like a data warehouse just for the dashboarding queries, and then another one, let's say, for the ETL queries. So you separate them manually, and then you connect them through data sharing so that they work over the same data. Unfortunately, this doesn't solve the full problem. So first of all, it's a manual process. You need to constantly monitor what workloads belong to where and how to size it. Right? That's like a problem. The second one is things might change. So let's assume like you perfectly sized it for the ETL workloads. But now, because ETL normally increases the data size, your data size slowly grows, queries are slowly coming a little bit slower until they violate actually your SLOs, like the service level objectives you have in mind. Right? So how do people deal with it today? It's like they actually continuously monitor what the data warehouse is doing, if it's still functioning correctly. They apply a whole range of like optimizations like materialized views, sort keys, other things. They create manual separation of workloads just to deal with that issue. We want to make it easier, and that is where the next generation of AI optimization and scaling comes in. Right? We want to make this part easier, that it scales really on the real demand of your workload, not just based on the concurrency. Right? So it's a new intelligent scaling mechanism. So how do we do that? The first thing is really like this very large query which is coming in. We want to solve that use case. Right? So if a large query comes in, we analyze it on the fly, and then based on the demand of that query, we actually allocate potentially more resources beyond the base capacity what you selected. Right? In fact, I'm using just the query here as an example because we do it more like over the current workload which is coming in. It's not just like one query we are doing it for. It's more like the current situation of your workload, and we analyze every single individual query, but then also consider it as like the current set what's going on. So we don't just make individual decisions, it's more like what's currently on your cluster at the same time. And so that's a new on-demand scaling mechanism which constantly monitors what the real demand needs are from your workload. So how do we do that? Like on one hand, we improved our query prediction models. So now we can predict much more precisely how much memory a query needs, what the demands are on I/O, and for what the latency, the predicted latency will be if you start running it. In addition to that, we built new like scaling predicting models which actually tell us an estimate on how a query performs if we would scale it up on a different numbers of like nodes or machines. Right? So if you increase the capacity, we get an estimate on how the query behaves on that one. Right? So we take this information into account and then make a decision based on that. Unfortunately, like models take time. Right? Our most advanced models actually might take longer than actually executing the query, particularly if you have a short-running dashboarding query. Doing this inference to figure out on how a query might scale might be longer than actually just running the query. Right? So we need to wait to deal with that. Luckily, there's one thing which we observed on our fleet is a lot of queries actually repeat. Like in fact, we found that over 80% of our queries have been seen before. Right? So the best predictor we can actually build is if you see a query which has been run before, use the last runtime we observed. Right? That's a pretty good predictor. Unfortunately, things might change in between. Right? Like maybe the data size increased, maybe there's a different predicate, which is then not exactly the same query, but maybe the first was a template, so there are like certain variants. So instead of just like doing a cache on the query text, we actually do the cache on the feature vector of a query. So a feature vector you can think of, it's a embedding like a bunch of properties we have about the query, including the data properties. So it's a typical machine learning model which embeds the information which normally a query has after it was compiled and optimized. Right? If we find a cache value on the feature vector, we return it, and it's super fast. It takes no time. If we don't find the cache entry, we actually go to a local small model which makes a quick prediction, and the main goal of that model is to figure out if a query is short or long running. If it's short running, we're actually fine because we probably just want to schedule it and don't spend much more time on it. If it's long running, then we go through another stage of predictions which actually give us this like scaling properties and other things, which might take longer, but then we get all the information we need to make the right scaling decisions. And so let's assume this all works now, and we implemented it. It actually does. But the thing is now, how do we know on how aggressively we should scale? And for that, let's talk a little bit about like the scaling properties of typical queries. Right? So for the moment, assume you have a query here. It takes currently 8 minutes to run, and it costs you $1 a minute. And we just assume this query occupies the entire cluster. Normally, we would talk about a workload. Here, just for simplicity, we use a single query. Right? If I can run this query on twice the amount of resources, I would pay $2 a minute. But if the query behaves perfectly and runs twice as fast, right, then my total cost would be still $8. I pay now $2 per minute, but it only runs for 4 minutes. Right? So I get better performance, and the cost stays the same. We talk in that case about linear scaling. It's like the property we'd like to have in the end. Right? In some cases, even we got into a regime which is super linear scaling, which sometimes it happens if you double the amount of resources, the query actually goes faster than 2x. This particular happens if the query before was constrained, let's say by memory. Like the entire intermediate working set didn't fit into my memory, and you started spilling to disk, like you had to write data out to disk, bring it back in as you do the processing. In the moment you give it enough memory, suddenly everything works faster, and overall it runs shorter than just like the 2x additional amount of resources you throw at it, and you even save money if you do that. The nice thing what we give is the next generation of AI scaling is that if it's either linear or super linear, so it doesn't increase the cost for you, we always do it for you for free. We always do that scaling. If you can detect, it doesn't increase the cost and it just gives you better performance. Right? That's a new thing which wasn't like possible before. However, there are also the cases where this is not true. Right? So let's assume like we doubled the resources already. Now the query runs in 4 minutes. It costs us $2 a minute. But now if you would double the capacity again, let's say to that we have to pay $4 a minute, now the query runs actually for 3 minutes, not twice as fast, a little bit slower. Right? So now our total cost increases from 8 to 12, but at the same time, we do get the speed up, just not 2x. So the question is this worthwhile doing or not? Right? And actually there's a theory behind that which is called Amdahl's law, which defines that eventually every application, every program you have can be divided into a parallelizable part and a serial part, and you can only parallelize the parallelizable part and you will get this diminishing return effect. Right? So eventually everything will actually flatten out, and there's a theoretical limit on how much you can actually scale something. Right? So how do we deal with that? It's just like, this is where the user comes in. We need your feedback because we cannot like know without any additional information how much you prefer performance over cost. Right? So this is why we're introducing a new slider. So there is no base RPU anymore. You don't pick like a base cluster size. Instead, you say where you want to be on the performance price spectrum. If you pick a point on the far left, you optimize for cost. What we pick automatically for you is the optimal data warehouse size where everything scales linear, right, or super linear, and you get the best actually price performance possible for your workload. This is not necessarily the smallest data capacity available, it's the best price performance we can do for you. Right? It might actually be a little bit larger because we want to avoid the spilling things that I talked before about. As more you move the slider to the right, the more you prefer performance over cost, right? And there's like a certain overhead you are willing to take, but you get better performance for it. In addition to introducing the slider, we are also introducing additional cost controls because we know you care about, like, that, for example, never the cost goes up around like a certain value. So you can also specify that. Right? But the core idea is just like, instead of thinking about the hardware you need to allocate now, you have the slider where you say like where on the like cost performance spectrum you would like to be, and we do everything else automatically for you. Moving on, we already talked about this like on-demand scaling capability. Query comes in, we do all these predictions, and we scale accordingly. Unfortunately, this is in some cases not enough. And this is particularly true for short-running queries, because there's a thing, it takes us a little bit of a while to add additional capacity. If everything would be immediate, on-demand scaling is the only thing you need, because you can immediately react, but unfortunately there is physics, right? It takes simply some time to load data from disk, it takes some time to allocate enough resources, and like in the end, electrons only travel at like 1% of the speed of light, right? So there's something we need to work around that. And this is why we're also introducing a forecasting mechanism which looks into how your workload actually behaves over time, and then based on that makes also like allocation decisions, particular for the short-running queries. Because we don't want to have the short-running queries impacted by bringing our capacity on demand when it's already too late and we would delay them, right? We want a little bit more proactive about them, right? The nice thing about these forecasting mechanisms is that it also allows us to do other things. Because in the moment we have a forecaster, we can predict a little bit into the future what to expect next. We can actually make optimizations based on that. And a whole range of our autonomics efforts are in that space. Meaning, for example, we use this forecasting to decide what materialized views might be beneficial for you, which can again lower cost if done right. Or what sort case you can use to like skip over larger amounts of data. Or a new thing we're actually introducing, like complete new sort key orders, which can help to even further improve the cost. So this also launched, it's a new way to sort data. It's called multidimensional data layouts. So in contrast to like picking a normal sort key or hierarchical sort key, which normally the user has to do, multidimensional data layouts organize the data in a multidimensional space. You can think about it as they observe what predicates you have most common, and then based on these predicates, group up the data in ways, put them into block on storage so that you can skip over large amounts of data you don't need for a particular query. It's a new technique. As far as I know, it wasn't done ever before in that sense, and we see huge speed ups, up to 74% runtime reduction compared to no sort key, or 40% to the best manual picked one in some of our experiments. So now putting it all together, here I have like a simple setup where I have like a base workload of short-running dashboarding queries and then a period of some long-running queries. So let's look first on how Redshift today, before this like next scaling mechanism, the AI-based one, was introduced, how it would behave. So we have the short-running queries running, we have a base capacity of 32 RPUs. At some point in yellow, the large queries start. They create this like queuing effect. A burst cluster was created for that because as things queue up, the concurrency level goes up. We create another burst cluster of the same size again, and then in this case even a third one, right? And then eventually everything shuts down again. So this is like the current behavior. What you would see is just like it creates based on this like concurrency threshold the different things. So now with the new scaling mechanism, we actually are smarter more about it. So we have the same workload in the beginning, but then we detect the long-running queries come in, they need much more capacity. And here we allocate a larger capacity on demand to it. And we even find that this larger capacity of, like in this case, 256 RPU, is even able to handle all the dashboarding queries as well. So we shut down the original smaller cluster completely. And then at some point, when the large queries are done, we bring it over again. Right? So very different scaling behavior. As a result of that, the average latency over both short and long-running ones is reduced by a factor of 10x in this experiment. The latency of long-running queries actually improves even more. We also improve the latency of short-running queries because they're no longer impacted by the long-running queries. We have a slight cost increase here because the slider position wasn't set to like just cost savings. It was like more the balanced one. So we favor performance over cost, but overall we give you a 10x better price performance for this particular workload. Right? So with that, I will hand it over back to Ashish, who gives you now a live demo and you can see it in action.
Thank you, Professor Tim. Now that Tim has taught us, physics and, Amdahl's law and how the auto scaling works, let's see actually his principles in action here. Okay? So the first demo is I'm going to show you how easy it is to create this new serverless with the new AI-driven scaling and optimization technique. I have pre-recorded in interest of time and, because of, not to rely on the Wi-Fi. So, so let me do this, and the video may have been fast forwarded. There is a preview, it's in preview. I would give it a name where you create your compute my AI driven work group. And so you give it a name, and then you see the price performance target. This is where we provide you the control is in your hands. You decide if your workload is more sensitive, you choose optimize for cost. Let's do next, and then give it a namespace. It's a storage, basically where you store your data. So I am giving it a name and selecting my IAM policy to the user, and then say next and review. As you see, I'm sensitive to cost, so I selected optimization for cost, and I will just submit it. And the work group starts getting created. So it's creating the work group right now, and on the bottom also on the list you can see that work group is getting created. Let's give us few seconds. It will get created, and you can review. So you see that it has got created with optimized for cost. So any workload that it will be running will be, keeping cost in mind. You are welcome to change it even later on, okay? So you decide that workload needs more performance. You can change the slider quickly and save it, and all the optimization henceforth that will occur will be for performance. Okay? So that was my first demo. Okay? And you can see that it is now optimized for performance. All right, so within few seconds you can create your serverless endpoint, and you can change your settings later on if you need to. Okay, so that was the creation part. Now let's talk about some real world scenarios here. I have 3 specific demos. The first one is a long running query. A data analyst or a data scientist has written some complex query that was never seen before. It's a long running query. I'll show you how this new AI scaling and optimization technique responds to it. How does it scales? What capacity it uses, and what's the cost for us. Okay. And the second one is when you have high volume of ingestion coming in, like your copy command. You have data size of various files. I'll show you a scenario where I have copied 3 times more data, and how does this serverless with the new technology scales up. Okay. And the next one is we do downscale also. Okay. Remember that. So in this scenario, the third scenario, I will show you how did we downscale basically automatically because you have decided that you are sensitive to cost here. So the warehouse scales automatically down. So let's talk about these scenarios here. Okay. So basically, I do have 2 work groups that are available to me. The first one is the normal, serverless work group with the base RPU that you specify. It's 32 base RPU capacity that I have. And the second work group I have is with the new AI-driven scaling and optimization technique. And I have this big giant query, and again I have fast forwarded the video in interest of time. It's running against a sales catalog with over 1 billion rows. You can see that the query is complex and the data set is large. This query is coming in for the first time, and my slider settings are optimized for performance. Okay. So what I do is I'm going to run this query against the regular, with base RPU of 32 serverless data warehouse instance, as well as I will run it against the new AI-driven technology serverless work group. And let's see the capacity use, the performance of it, what's the elapsed time for this query, and what's the cost for this query. So it's running against the regular one right now. And I also ran it against the next gen serverless workgroup. So let's see, it's running right now. It returned the results more quicker on the next gen serverless workgroup. So this is, I'm now checking, the time it has taken in the regular one, and also the capacity and the charges that it has used. So it's a 32 compute with about 56,000 charge seconds that this query has used. Let's do the same thing against the new serverless workgroup that we created. And you can see the duration is just 170 seconds for the same query. With the new AI-driven technique, it is just 170 seconds basically. And now see the charge seconds. The charge seconds also reduced here basically. I'm summarizing this in my Excel spreadsheet here. The query runtime with the regular base workgroup was 2008. The cost was $5.93. And with the new next-gen AI optimized instance, the timing got reduced by 170 seconds. And not only that, the cost also reduced here. So there is a big price performance benefit, and this is exactly what Tim was explaining. By assigning more resources, you actually saved on the cost. So that's the benefit of using this new next-gen AI optimized instance. Okay? So it solves our pain point of this long-running workload that comes in. So that's my first demo. Now the second one, let's talk about the second one, where we are ingesting more data. The data files has more data. So you can just quickly see that I have a copy command. I'm running to run two copy commands. My files are on S3. One is with 720 million rows, and the other one is with 2.1 billion rows. Okay? And I'm going to run this against the regular today's serverless, as well as with the new AI-driven serverless workgroup. So let's do that here. So you see I'm doing a copy command. I do have my files in S3 with 720 million records. And the second one is with about 2.159 million records. So let's run this against the regular workgroup and the next gen workgroup, both, and see how it performs. We'll check the capacity, we will check the cost, we will check the elapsed time that it has used. Okay? And we'll compare those again in the Excel spreadsheet. All right, so let's run it. So I'm running it against the regular work group here right now, okay? And I'm running it with the next gen also at this, it's running. So now let's see, as you can see that it has loaded 720 million rows, and it has the second query has, the second copy command has loaded 21. And let's validate for the new work group. Both have been loaded successfully. Okay. Now let's check the elapsed time using the sys query history. Okay. And you can see 174 seconds, and the second one is 560 seconds in the regular work group. Now let's do the same in the new serverless work group. What happens there? Okay. Charge seconds, let's see the total here. Basically, let's see let's run the query again here. Okay. So the charge seconds, 12,704. Let's see the times. Okay. Again, with the new serverless work group. Okay, so you can see the first 720 million rows got loaded into 179 seconds, and the second one got loaded into 122 seconds. So you loaded 3 times more data, but it got loaded faster. And let's see the cost here. Okay. The cost for first one was 1920 charge seconds, and the second one was 3456. So it did costed you more basically to load the data faster. My settings there was for optimized for performance. The work group scaled, the compute scaled here, and I will summarize it for quick understanding. 720 million rows took 2.9 seconds and costed 58 cents, whereas in the new work group it costed pretty same, in the same ballpark. But look at the 3 times more data. In the regular work group, it took 9 minutes 33 seconds and costed $1.30 approximately. But look at these numbers. In the new work group, new AI-driven work group, it for the 2.15 billion rows, it just took 2 minutes, roughly 2 minutes approximately, and the cost was more. You get a big boost in the performance actually. So if you are sensitive to loading workload, you want to load it as faster as possible, this is a great solution with optimized for performance. Right? So that was my second scenario. Now let's talk about the third scenario. Again, this is a pre-recorded one. I had ran the workload on 11th of November. My goal there was to save on cost. Okay, that was my goal. And we were seeing this workload for the first time. That's the input. I wanted that control. We had a budget. So I wanted to save on the cost. So what we will see is the workload ran for the first time, what was the capacity used, how much time it took, and what was the cost related to it. And then the workload came in again automatically the next day. We'll measure the impact of this new AI technology that we are talking about here. Okay, so let's do that. So you see on the 11th of November, I ran this workload. Okay, and these are roughly about little bit over 1900 queries. 1977 queries, took on an average 1.39 seconds. This was on 11th of November. I ran it actually. Okay, and let's see what the capacity was used. Okay, so capacity used was 128 RPU. RPU is the Redshift processing units. 1 RPU gives you 16 GB of memory. Now let's see what happened on the charges on 11th of November. Okay, so around 728,576 charge seconds, because we do charge based on per second basis. And let's do the same thing on 12th. So the average time is 1.9 seconds for pretty similar, the same workload. But so the performance went down from 1.3 seconds to 1.9 seconds. Okay, but let's review the capacity. Now the capacity is 64. Earlier, remember, it was 128. Now it is 64. The next day on November 12th, and let's see the cost. 59,000. Earlier it was around 76,000. To summarize it, on an average, I ran over 1900 queries. The average elapsed time was 1.39 seconds. Compute used was 128. Costed me $75 approximately. But because of the AI scaling and optimizations, it downsized the compute automatically. You did not have to take any action, and my cost was $61.85 approximately, and that resulted in savings to you. So that's the benefit of this new AI-driven technology that you will get automatically. It's completely hands-off. Just tell us what is your workload, what are your limits, give us that input, and we will automatically take care of it. So I want to conclude this. What are the benefits of using, this new AI-driven scaling and optimization technique? Up to 10x price performance benefits you can get from this. These are tailored performance optimization specifically for your workload. It will eliminate the manual effort that we all are spending time. And the fourth is it will avoid the performance cliffs and timeouts that you may experience for your long-running workloads. So that's my conclusion here. I encourage everyone to try out Redshift Serverless. $300 free serverless credits is available to you. If you're a new user, I highly encourage to try out this new technology. You will be very pleased with it. A nice blog will be available to you that describes this feature in more details. And with that, thank you for coming in and listening to us.